Hello, my name is JAnderson, and today we are going to discuss the Pluralsight video we watched this week on how to harden a network from a software perspective. The lesson began with the definition of a service and malware. It went into anti-malware software and the uses for that, as well as secure protocols including FTPS and SFTP, how TLS works, which is the current version of SSL, how TLS and hashing work together, and the overall basics of authentication and authentication protocols. As we begin, we looked at the definition of a service. A service is essentially something that is created that works in the background that transfers data from one data point to another. Obviously, the majority of the time you're going to want the data that you're transferring to be secure, which gets us into the next security protocol piece. But it's important to know and understand that before you look at secure protocols in transmitting the data, you'll also have to make sure that you're containing and securing the local PC or the server from any malicious software attacks. To do that, you can use an anti-malware software that will detect and contain the malware when it is on the PC or the server. Secondly, we look at secure protocols, including FTPS and SFTP. Initially, I thought they were the same thing, but through this lesson, I found out that they are 100% not the same thing. FTPS uses certificates, where SFTP uses pairing keys. To help illustrate this a little bit more, I put together a high-level flow chart to help me understand the workflow when a secure protocol is in place. And what I determined that is that the client is going to request a connection to a server. Whether that server is inside the firewall or outside the firewall, it's going to request that connection, and the server is going to receive that request and send a certificate back. When the client receives the certificate information, it needs to determine that that certificate is from a trusted source. Part of the information that is sent back from the server includes the source of the certificate. The local PC contains a list of all of the trusted sources that are acceptable. If the certificate is from a trusted source, the client is allowed to connect and uses authentication procedures such as one-factor, dual-factor, or multi-factor authentication. From there, the client is allowed to send and request information from the server in a secure manner using encryption or other options. The next thing we look at is authentication basics and protocols. Much like I mentioned earlier, you can have multiple levels of authentication. You can have a single source authentication, which is a single sign-on, or username and password. At my company, we use multi-factor authentication, which means that in addition to the username and password, we must also have another level. And in our case, it's a token provided through an application that sends and authenticates your user information through a cell phone. Lastly, there is multi-factor authentication. This can use things like username and passwords, tokens, and another third source or more depending on the business. All in all, this week's lesson was very enlightening. The concept of secure versus non-secure transmission has always been something that I was aware of when you have the S at the end of HTTPS. But to go a little bit further, I actually logged into my bank. I wanted to see what the certificate was and who the trusted signer was. I was able to find that information and then look at my local machine, and it determined that VeriSign was a trusted source. Furthermore, I looked into details on the sites like GoDaddy.com, who provides the trusted source levels to ensure that not just anyone can create a website or a certificate that is not authentic from a trusted source. All in all, this lesson was very, very informative to me, and I learned quite a bit. Thank you for your time today. I hope you have a pleasant afternoon.